Hi, today you can do the PAT paper in 2010 looking at question 1. So question 1 is split into two parts. Part I says to solve sine of 3x equals root 3 cosine of 3x for x in the range of 0 and pi. Okay, well the first thing we know is we notice that we have not single angles, we have 3 x's as the angles. So that's something to think about later on. So what we'll do is we'll divide across by cosine of 3x to get sine 3x over cos 3x, which we know is tan 3x. So we see that this means tan of 3x is equal to root 3. Well, let's draw a quick sketch of our tan graph. So we know it has asymptotes at minus pi by 2, pi by 2, 3 pi by 2, and so on. And it looks like this. So what we notice is that in fact tan is periodic with a period of pi. What that means is every pi, it repeats itself. So if there's a value here, which gives us a solution, there'll be a value here that gives us a solution. So what that means is, when we find our solution in the range here, for tan 3x equals root 3, you must also consider solutions in here and here and here and so on. So we know that tan 3x equals root 3 implies that 3x equals to, well we know pi by 3 is the solution, plus n pi for an integer n. So that's for n an element of the integers. So that simply means n is an integer. So i.e. 3x will be equal to pi by 3, add pi, 4 pi by 3, or 7 pi by 3, and so on. Divided by 3 tells us that x is equal to, well, pi by 3 divided by 3 is pi by 9, that's in the range. 4 pi by 3 divided by 3 is 4 pi by 9, that's in the range. And similarly, 7 pi by 9, that's in the range. But we notice if we considered 10 pi by 3, that would not be in the range. 10 pi by 9 would be out of the range. So this is the only values of x within the range of 0 and pi. Pi gives us cosine squared x minus sine x plus 1 equals 0. Now let's just solve this again in the same range. So what we do is always, we rewrite the cosine squared x as 1 minus sine squared of x, minus sine of x plus 1 equals 0, or sine squared of x plus sine of x minus 2 equals 0. And we spot this as quadratic, as always, so we can factorize this as sine x plus 2, sine of x minus 1 equals 0, which implies that sine x equals 1 or sine x equals minus 2. We notice sine x cannot equal minus 2, so there's no solutions there. So we only have sine of x equals 1. And sine of x equals 1 has only one solution in the range of 0 to pi. So if we sketch that out, we see it looks like this. And we see it's only here that we have a solution. So we see x is pi by 2.